And today we got this problem, this very beautiful problem, which is this, that limit of x cos 1 by x equals to what, okay, and x tends to 0. Got it? So if you just watch this function, that x cos 1 by x, at first you have to think that what is the domain of this function, and the domain of this function is generally r minus 0, because you can see that cos 1 by x, you cannot define that function in 0. Okay, so you delete the number 0 from the whole r, and the function is very basically defined. Okay, that is the first thing. Now you have to define you have to determine the limit at x equals to 0. So if you talk about the domain, is basically r minus 0, and 0 is basically a limit point of r minus 0, so it is well defined. This question is valid. Okay, now you try to find the limit. So there are basically two ways to find the limit. One is called the sandwich theorem, which is very beautiful theorem, but this problem can be solved without applying the sandwich theorem, and it is called the null limit. Okay, it is sometimes called the null limit or the nullity of limit. So the thing is like that. Let's say that there are basically two functions. Okay, generally there are two functions like this. One is f, one is g. One function f is basically bounded on the domain or on the neighborhood of that point where you have to define the limit, and another function g, which basically goes to 0 at that point, means the limit of g is basically 0. So then if you take the limit of fg at, let's say, that particular point could be 0, because one function is bounded, so there is no variation of the function, there is no indefinite variation of the function, and one function is 0, so this means the whole thing gonna be 0. So we basically apply exactly that theorem, and you can prove this. Okay, now you generally see that here limit of x as x tends to 0 is basically equals to 0. So that is the function which basically 0. So that is called the null limit. Another function which is called cos of 1 by x, and it generally less equals to 1. In basically any neighborhood of 0. Okay, in any neighborhood of 0, this function is bounded. So from that you can just see that limit of x cos 1 by x is basically equals to 0 as x tends to 0. Okay, so that is the simplest method to determine this kind of not tough. It is seemingly hard, but not that much hard. This kind of limit. And even if you replace this x via something else like this, if I replace x like this, that limit of x to the power p cos of 1 by x, this again should be equals to 0 as x tends to 0 if p greater than 0. So if p is greater than 0, then limit of x to the power p cos 1 by x, that should be equals to 0, because x to the power p always tends to 0 whatever happens to that positive p. Okay, if the p is positive, then everything is fine. Then x to the power p basically goes to 0, and this basically is, let's say, equals to 1. Okay, so of course this kind of thing only can happen when you have like trigonometric function like cosine x or sin x. Otherwise it can happen. Okay, so thanks for watching.